this graph with the catalyst and without catalyst. Is there any doubt that you have?
No, sir.
Okay. So see, this is your collision theory of chemical reaction. So basically, whenever reaction occurs, there will be collision between reactants, and there is a term that is collision frequency. What does it mean? So basically, it is number of collision per unit volume per second. That is called collision frequency. So I'm going to write the definition first of this collision frequency. Write with me the number of collisions per second per unit volume per second per unit volume of a reaction mixture is known as collision frequency. So basically, the collisions per second per unit volume, that is called collision frequency. Let's say if we have a reaction A plus B giving us product. So there is an equation for this collision frequency, and according to that reaction, we have an equation of rate, and rate will be equal to ZAB. That represents basically collision frequency of A and B reactant into E raised to the power again A upon R. So I'm gonna write what does this ZAB means. ZAB means basically collision frequency of reactants A and B. Collision frequency of reactants A and what is this E raised to the power minus E upon R2? So this E raised to the power minus E upon R2 is the fraction of molecules. This is fraction of molecules with energies equal to or greater than activation energy. Equal to or greater than activation energy. So please do write it.
Done, sir.
Very good. So this collision frequency, you got it. Now, for occurring of any reaction or for a reaction, we have two other factors that defines the reaction. That is proper orientation and the steric factor. What does this proper orientation mean? So I'm going to write a point and then I will explain with the help of a reaction. Write with me. The proper orientation of reactant molecules leads to the formation of product, leads to the bond formation. Bond formation. Whereas improper orientation makes them simply bounce back and no product is formed. So it's very easy to understand. If you are carrying a reaction which has a proper orientation, then the product will form. And if the reaction does not have any proper orientation, then the product will not form. Again, I am going to repeat. If you have proper orientation, then product will form. And if you don't have proper orientation, then product will not form. Nafisa.
Yes, sir.
Okay, I'm going to slide it up and then take a screenshot. We just started. Let me know when you're done with this.
Done, sir.
Okay. Nafisa, we just started with the collision frequency or collision theory of chemical reaction. Whenever chemical reaction takes place, there will be collision between the reactant per second per unit volume. That is known as collision frequency. According to this collision theory, we have an equation that is rate is equal to ZAB e raised to the power minus E upon RT with respect to this reactant, this reaction. So you can see this rate equals to ZAB e raised to the power minus E upon RT. This ZAB is the collision frequency of reactants A and B, and e raised to the power minus E upon RT is the fraction of molecule with energies less than equal to or greater than activation energy. Is that clear, Nafisa?
Yes, sir.
Okay, screenshot.
Yes, sir. We took.
Okay. Now, for a reaction to occur, there is another factor that is called proper orientation. If you have proper orientation during a reaction, then bond formation will take place. That means the product will form. And if you don't have proper orientation, then the bond formation will not take place and the product will not form. What does this proper orientation means and improper orientation means? I'm going to take an example to explain this. So just take a screenshot. I'm going to slide it up. Done. Okay, let's start. Just suppose if we have bromomethane, that is like this. If you have bromomethane and OH minus, you have seen this reaction in haloalkanes and haloarenes. So if you are going to react this like the way I'm going to do it, you know that this is bromomethane and methyl bromide, and here you have hydroxide ion, and you know that bromine is a good living group. So what bromine will do, it will take electron from carbon, and it will start living in this compound. So there will be positive charge on carbon and there will be negative charge on bromine. So when bromine will take electron from carbon, it will go out from this, and this OH minus, which is a nucleophile, will try to attack on carbon. But you can see they are coming in each other's way, and they both have negative charge. Bromine is Br minus is there, OH minus is there, and since they both have negative charge, and we know the nature of charge that uh, like charges repel each other, so it's not possible for OH minus to go and attack on carbon, because there will be repulsion between Br minus and OH minus. So this will be your improper orientation. Improper orientation. Is that clear?
Yes, sir.
Nafisa,
Yes, sir.
now see, I'm going to take the proper orientation example. If you are going to write this PBR and then this H and then this H, and then you have another H, and you have OH minus here on the back side, and you can see that this Br minus will go, so it will have negative charge, this will have positive charge, so this OH minus can easily attack on carbon, say carbocation, because there is no negative charge that is stopping OH minus. So there will be bond formation. This will be OH, this will be H, this will be H, this will be H, and Br minus will be here. You can see that. So this is your proper orientation. So in a reaction, there must be proper orientation so that the product formation will take place. Otherwise, the product formation will not take place. Let me know when you are done with this.
Done, sir.
Nafisa, are you done with this?
Yes, sir. Finish.
Very good. Now we have another factor for reaction, chemical reaction to occur, that is a steric factor, and we have an equation for that too. The rate is equal to P Z A B into e raised to the power minus EA upon RT, and in this P is basically a steric factor. What does this mean? A steric factor. What does this mean? As you can see that if I'm going to take an example of this CH3 Br, I'm going to take like this. This is Br. It's the example of SN2 reaction that we have already covered, and then we just took this example. Then I took this example. Then I took this example. All are CC. Not this is not O. Just don't take right it O. Just focus here, please, everyone. Hydrogen, hydrogen everywhere, hydrogen everywhere. Here it is C H3. I am directly writing H3. Can anyone tell me? Oh, which I'm writing here. Can anyone tell me? I'm writing here. So since this BR will is the living group, so it will go from here. So it will go from here and it will go from here. In which this OH minus can easily attack on C. In which OH minus can easily attack on carbocation. What do you think? In which OH minus can easily attack on carbocation? A, B, C, D. Let's say this is A, this is B, this is C, and this is your D. What do you think? If you don't have any idea, just let me know. And if you have idea, then also let me know. Nafisa? Sneha, do you have any answer of this? Am I audible to all of you? Okay. So see, Sneha, you can see that there is very less crowd across this carbocation. Less crowd. You can see in case of B, there is more crowd than the first case A. And in case of C, you can see there is more crowd than B. And in case of D, there is much more crowd than A, B, or C. Are you getting my point of this crowdness, a steric factor, a steric hindrance?
Yes, sir.
So in which a steric factor or a steric hindrance or the crowd is more? In D. So it is difficult for OH minus to reach here. So if in a reaction there is less crowding in this type of reaction, if there is less steric hindrance, then the reaction will easily process. But if you have a steric hindrance, bulky group, then it is not that much easy. Are you getting my point?
Yes, sir.
Please do write it. So this chapter is completed here. And I think here the block is deleted in your syllabus, right?
Yes, sir.
We will cover that P block and all the deleted chapters after completing the board syllabus. Do let me know if you have any problem with this. Do let me know when you are done with this.
Done, sir.
Very good.
Yes, sir. Finished.
So I was about to discuss something that is very important to discuss. Basically, in the next week of Saturday, that means This Saturday is on 26th, so the next Saturday comes out to be 3rd December. 3rd December, and I will not be available on 3rd December, so I want to take your class on 2nd December instead. On Friday, basically it's Friday, and I think all of you are free on that day. So if it is possible for everyone, like only 2 students are present here today, so just let me know. So will you be able to take class? Tomorrow's class is on time. I'm talking about the next week.
Yes, sir.
Yes,
Nafisa,
sir. Fine.
okay, Neha, you were not in the class on that Friday. So please, I'm requesting you to be in class on
Yes, sir.
2nd December. You will be updated. You will be updated after before that Friday. Now let's start some questions since the chapter completed. There are some important questions that has been regularly asked in your boards. So be careful. The question is very easy actually, but it looks tough. The question which looks tough generally are not that much tough. The following results have been obtained during the kinetic studies of the reaction. During the kinetic studies of the reaction. And the reaction is your basically 2A plus B will give you C plus D. Here is the experiment. Here is your A, that is in mole per liter. A is concentration of A is given, concentration of B is also given, mole per liter. This is actually box that I am going to make. And here also it's given that initial concentration, rate of formation. I'm going to write FORMN, that represents formation of D. As you can see, A and B is your reactant and C and D is product. Formation of D, and that is in mole per liter per minute. Actually, in rate law expression, we don't deal with the what we call it concentration of reactant. We deal with the rate. Now, in the first experiment, it was found that A has a concentration 0.1 and B has a concentration 0.1. Then the initial rate is 6 into 10 raised to the power minus 3. In the second experiment that you have found that A has the concentration of A has increased 3 times. Now its concentration is 0.3 and B is double 0.2 and its concentration the rate is changed to 7.2 into 10 raised to the power minus 2. The third experiment shows that A has concentration as the second one, but B is double of the second or 4 times of the first. Now the rate is 2.88 into 10 raised to the power minus. Now the fourth experiment comes, and here you can see that this has a 0.4, this has 0.1, and this is your 2.40 into 10 raised to the power minus 2. Please do write it and then let me know. I will write the remaining portion of the question. Do let me know when you are done with this. Are you done with the question?
Yes, sir.
Oh,
Yes,
only
sir.
you are left. Okay. Are you there, Nafis? Okay. Both are. Thank you. So I'm going to write the remaining portion of the question. Actually, the question asked that with the help of this information, you need to determine the rate law and the rate constant and the rate constant for the reaction for the reaction. And in order to determine the rate constant, you have to know the order of reaction basically, and that order will be solved on the basis of rate law. Constant for the reaction. See, what I told you in the reaction, in the rate law expression, this is an experimental quantity. I told you, and the experiment is given this, and with the help of this, will you be able to calculate the rate law? And if you are going to calculate the rate law expression, then you can easily calculate the rate constant. The rate constant. So please do write this question up to this and let me know whether you will be able to solve it or not. There are two ways to solve it. One, you can solve it in a few seconds. That is only for competitive exams, but in your board exams, there must be in need of subjective, like you need to write all the process that you are thinking so that you can get full marks. Please do let me know. Will you be able to solve it or not? I am waiting. Are you done with this?
No, sir.
Okay. So please make an attempt. Then if you are making, I am waiting. There is mathematical calculation in this question. Very good, Sneha. You have got the right answer. That is, rate is equal to k into a into b square, b raised to the power 2. Now you need to define k for each reaction. So k will be equal to rate upon A into B raised to the power 2. For this, rate constant will be equal to, as you can see, rate is given 6 into 10 raised to the power minus 3 upon what is the concentration of A? It is 0.1 into what is the concentration of B? 0.1 raised to the power. In this way, you can get the rate constant value of this. Again, same you can do for this. K is equal to rate has a value this 7.2 into 10 raised to the power minus 2 upon A has a concentration 0.3 and B has a concentration 0.2 square. Got it? The second question of this part, that is rate constant, can be defined in this way. Is that clear? And as you know that rate constant, basically this constant only depends on temperature, only depends on temperature. So if you are going to calculate the rate constant, it will be same for each experiment. Nafisa, have you got the answer? Yes or no?
Sir, I did that, but I think my calculations are wrong.
Should I explain it? Should I explain it or you are calculating it again?
Sir, yeah, I can calculate it again.
Please do it faster. Please do let me know when you are done with this. I'm going to give you another question.
Done, sir.
Very
Yes,
good.
we finished.
Now I'm going to give you some questions and this will be for your test. That. So please do write the question. In tomorrow's class, we are going to start a new chapter. Which chapter we are going to start? Aldehyde, right? Your first question. Let me know when you are done with these two questions. Then I'm going to write three more questions.
Yes, sir, finish.
What about you, Sneha? Please do respond.
A second, sir. The second question.
Okay, I'm sliding it up slightly. Sneha, please do let me know when you are done with the second question.
Done, sir.
Very good. Write the third question. This is the concentration, that is 1.63 into 10 raised to the power 2, 1.636 into 10 raised to the power 2, 1.14 into 10 raised to the power 2, like this. Okay. And then question will be asked. Please do this first. Are you done up to this?
Yes, sir.
Yes, sir.
What you just said, Sneha?
That, sir.
Thank you. The first question asked is plot the concentration of N2O5 against time against T. The second question is find the half-life half-life period for the reaction. C is draw a graph between log of N2O5 and T. D is what is the rate law? E is calculate the rate constant. F is calculate just cut the F. The last question, I'm not going to give the 5 question because it's already lengthy. Fourth question is the rate constant for a first order reaction is 60 per second. How much time will it take to reduce the initial concentration of the reactant to its 1/6 value? Please do these questions. Nafisa, are you done with this?
Yes, sir.
Okay, please send it in PDF form.
No, sir, I'm still doing. I'll send it later.
Okay, okay, okay.